Hello, welcome back to Learn Physics. In today's topic, we are discussing about the same chapter, that is electric charges and fields. In last class, we learned till electric dipole. For an electric dipole, if we are considering a point on the axial line and a point on the equatorial line, what will be the electric field? There we saw the electric field in a dipole means it will be inversely proportional to r cube, and in the case of a point charge, single charge what we are considering, electric field is inversely proportional to r square. That two values we discussed, isn't it? So today we are going to find out what will be the torque acting on a dipole if it is present in a uniform electric field. Okay, in the case if a uniform electric field is present in a dipole, what will be the torque? Or in a electric field, in a uniform external electric field, if a dipole is present, external electric field is there, a dipole is present over there, what will happen? Okay, so here we are considering two charges. One is minus q and another is plus q. Okay, it's like this. It's separated by a distance of 2a. Okay, an electric field is present. This is the direction of electric field. Minus QE will be acting in this direction and plus QE will be acting in this direction. So this is F is equal to minus QE. Here F is equal to F due to positive charge is equal to minus QE. Two equal and opposite charges, but their line of action is different. One is over here and the other is over here. Because of this difference in line of action, what will happen? A rotational effect will happen. Right, if QE and minus QE are acting in the same line of action, what will happen? Net force will be equal to 0. But here this is not the case. Here QE minus QE is acting over here and plus QE is acting over here. Because of that, net force will be equal to 0. Okay, so the net force is not equal to 0. Instead of that, a torque will be acting on the system. Okay, what is the formula to find out the torque acting on the system? Torque 2 equals R cross F. Last year we learned, right? R cross F we need to find out. What is R cross F? RF sine theta. This one we need to find out. Okay, so what is F here? F is QE. Okay, magnitude of F is QE, and what is R here? Perpendicular distance between R and F. Perpendicular distance between these two charges. This is perpendicular distance between these two forces. That is called R. Okay, so here QE is acting in this direction. This is E. This is the direction of uniform electric field, which is uniform electric field is acting on a uniform external electric field is acting on a dipole. Clear? So here this is electric field. This electric field is making an angle theta. Okay, if this is making an angle theta with this dipole, what will be this perpendicular distance? How we can find out this perpendicular distance? For that, see, this is 2a, which is making an angle theta here. So if this is electric field, what will be this angle? This also will be theta, right? So here I can consider this as theta, right? Then what will be sine theta? From here we can write down what is sine theta here. I can consider this as a triangle. Okay, Pythagoras theorem we can apply and we will get it as, so here, so this is 2a, this is 2a, and sine theta if I am taking opposite side, this perpendicular distance, opposite side divided by hypotenuse, that is 2a. Okay, that is sine theta. So what is opposite side here? Sine theta equals opposite side divided by 2a. Therefore, opposite side equals 2a sine theta. Clear? So this is 2a sine theta. Now, so we got the value of perpendicular distance between these two forces. Clear? So torque equals 2a sine theta into, what is one of the force? QE. Okay, magnitude alone I am considering. So I will get it as Q 2a into Q into E sine theta. What is 2a into Q? That is P. P into E sine theta. What is, if I am representing this as tau, vector tau, I can write it as P cross E. As per this cross product vector direction, in which direction it will be? It will be perpendicular to both P and E. The direction of torque will be perpendicular to both P and E. Clear? This is how we are finding out the torque acting on the system. Okay, in a uniform electric field, if a dipole is present, a torque will be acting on the system. That torque tau equals P cross E. If suppose this P and F theta equals 0, what will happen? If theta equals 0, sine 0, 0. Therefore, torque will be equal to 0. If theta equals 90, sine 90 is 1. So, tau equals PE. Okay, maximum value we will be getting for torque if theta equals 90 degree. That is, if P and E are perpendicular to each other, we will be getting the maximum torque. If P and E are parallel to each other, then we will get torque equals 0. Okay, if P and E are anti-parallel to each other, then also we will get torque equals 0. Clear? If theta equals 180 degree, tau equals 0. Here, see, these two are important. Okay, if theta equals 0, they are parallel to each other. Which and all? They are parallel means P and E. If P and E are parallel to each other, then we can say this dipole will be in stable equilibrium. Okay, torque is equal to 0. That means it is not acting any torque acting on the system. Okay, if both are parallel to each other, which and all, if dipole and electric field both are parallel to each other, then no torque acting on the system. They are called a stable equilibrium. And if P and E are anti-parallel to each other, that is 180 degree. If it is anti-parallel to each other, then we can say it is under unstable equilibrium. Clear? So these points also important. So if this is the torque acting on a dipole which is present in an external uniform electric field. Clear? Tau equals P cross E. That is the formula. If theta equals 0, then we can say it is in dipole is in stable equilibrium, and if theta equals 180 degree, then it will be in unstable equilibrium. Next we are going to discuss about if the dipole is present in a non-uniform electric field. Okay. So next we are going to find out if it is in a non-uniform field. If it is present in a non-uniform electric field. Okay, if the dipole is present in a non-uniform electric field. For that, this is minus Q and this is plus Q. Okay, so dipole, in which direction it will be acting? It will be from negative to positive charge. This is the direction of dipole. Okay, so P is acting in this direction. Now, electric field also acting in this direction. Okay, electric field is increasing in this direction. This is increasing direction. Okay, so here force is acting minus QE. Force is less force. Because electric field is less here. This is more force. So net force will be acting in which direction? Net force will be acting in this direction, because this is less force and this is more force. So which is the direction of more force? That will be the direction of net force. Okay, clear? So increasing field will be increasing electric field, and the net force will be parallel to each other in the same, not parallel, in the same direction it will be acting, but the net torque acting on the system will be equal to 0. So net force is acting if it is a non-uniform field, that is it is increasing from minus q to plus q. In this direction if it is acting, this is separated by the distance 2a, and it is increasing in this direction, that is here it is less electric field, and at the side of plus q it is more electric field. But net force will be acting in this direction, okay, in the direction of increasing electric field. Now I am considering this is minus q and this is plus q, and dipole is acting in this direction, okay, and increasing field is in this direction. This is the increasing electric field. Increasing electric field is in this direction. So here it is less force is acting, here it is more force will be acting. F is equal to QE. More force will be acting. Okay, so which will be the direction of net force? This is the direction of net force. Okay, so P and net force are acting in the opposite direction. Okay, if the field is increasing in this direction, but net torque acting on the system will be equal to 0. Okay, but here, so here you should see increasing electric field and net force are in the same direction. But here increasing electric field and the net force are in opposite direction. That means dipole is from minus q to plus q. Minus q to plus q means it is opposite to the direction of E. P cross E. P and E are in opposite direction, that is anti-parallel. Here it is anti-parallel. So in the case of non-uniform electric field, net force is present over there, because it is not, if it is a uniform electric field, what will happen? If it is uniform electric field, QE and minus QE, it will be equal to 0. Right, if it is uniform, net force acting on the system will be equal to 0. Okay, so but here in the case of a non-uniform electric field, if E and P are parallel to each other, net force also will be acting in the same direction. If E and P are anti-parallel to each other, then net force will be acting opposite to the direction of P. This one you should just understand, that's all. My increasing electric field is from negative to positive charge. So here it is less, here it is more force. So net force will be acting in the direction of more force. E is in this direction, P is, so E this direction, P also in this direction. Increasing net force also will be in the same direction. Okay, now here E is acting in this direction, P is acting in this direction. Net force will be acting opposite to the direction of P. Okay, clear? This is how we are. So in the case of uniform electric field, A and P are parallel to each other, then QE will be equal to QE minus QE will be equal to 0. Okay, so and if we are considering this torque, this and all in the same direction, parallel to E, Q and E are E and P are parallel to each other, then only we can say like this. Okay, clear? So here this is important and here this is important. And stable equilibrium and unstable equilibrium also keep in mind. If it is a non-uniform electric field, net torque acting on the system will be equal to 0 if P and E are parallel to each other, then we can say it is under stable equilibrium. If E and P are anti-parallel to each other, net torque acting on the system will be equal to 0, but it is called a unstable equilibrium. Clear? So yesterday in last video also we didn't do any numerical, so I told you to revise your write down and practice the derivation. Did you finish like that? See, if we are right, see, I can't come there and check. Okay, so whatever effort I am taking, see, this is the why I am telling like this is, many times I had seen my children, so while teaching they understood everything understood, but afterwards at the time of exam they won't be able to write down. The reason is they are not writing down and practicing. See, my teacher told me to write down and practice. If I am not writing down and practicing, next day while I am going to, that will be the homework, I should go there and show to my teacher. See, I did like this. Okay, that time some back pressure was there for me, but here I can only say through this. So please try to understand, and it's a see, each and every chapter now you will be having many derivations. Okay, and that too different type of derivations. Everything at a stretch you should remember at the time of exam. Okay, we are focusing mainly for our final exam, so please keep that in mind. If I don't want to give the advices in between, I don't like the giving advices, so please try to follow the instructions. Read aloud, write down and study, and remind the formulas in between. Okay, minimum 1 hour you should give for your subject. Okay, so shall we do some numerical today? Okay, so next first question is, two charges plus 20 microcoulomb and minus 20 microcoulomb are held 1 centimeter apart. Calculate the electric field at a point on the equatorial line at a distance of 50 centimeter from the center of the dipole. Okay, so here we know what is the formula to find out the electric field of a dipole if we are considering a point on the equatorial line. In the equatorial line, E is equal to 1 by 4 pi epsilon 0 P by R cube. P equals Q into 2A. 2A is the distance between the two charges. Here plus 20 microcoulomb and minus 20 microcoulomb. Q and minus Q, it is given 1 centimeter apart. 2A is 1 centimeter. Calculate the electric field at a point if we are considering a distance 50 centimeter from the center of the dipole. So shall we do? So here 20 microcoulomb minus 20 microcoulomb from the center, it is at a distance 50 centimeter from the, so this is the point, and next this 2A distance is given as 1 centimeter. So E, electric field, E is equal to 1 by 4 pi epsilon 0 P by R cube. Okay, so P by R cube, that is 1 by 4 pi epsilon 0. What is the value of 1 by 4 pi epsilon 0? 9 into 10 to the power 9 cube as 20 microcoulomb, that is 10 to the power minus 6. 2A is 1 centimeter, 1 into 10 to the power minus 2 divided by R cube 50. 50 into 10 to the power minus 2 the whole cube. So here 9 into 20 divided by 50 into 250 0 into 10 to the power, this is 3 and this is 1, so 10 divided by 10 to the power minus 6. So you can solve this and find out the final answer. Okay, unit is, what is the unit of this electric field? Newton per coulomb. Newton coulomb per to the power minus 1. This is the unit, electric field. What will be the direction of electric field in this case? See here, are you remembering this force is acting in this direction and here it is acting in this direction. Electric field is acting in this direction. So it is acting from minus 2. P is acting in this direction. So electric field is acting opposite to the direction of dipole. Here electric field will be acting opposite to the direction of dipole. Okay, clear? So E is in this, the final electric field 2E cos theta. Okay, in this direction minus q to plus q is acting in this direction P. Okay, so electric field is acting opposite to the direction of dipole. Clear? Next question is, the electric field due to a short dipole at a distance r on the axial line from its midpoint is the same as the electric field at a distance r dash on the equatorial line from its midpoint. Determine the ratio r divided by r dash. So electric field due to a short dipole at a distance r on the axial line. If I am considering a distance r on the axial line, from the center of the dipole will be equal to the electric field of a dipole which is on the equatorial line, which is at a distance r dash. We should find out r by r dash. That ratio only we should find out. For that we should know the formula. 1 by 4 pi epsilon 0 p by r cube is for equatorial line. 1 by 4 pi epsilon 0 2p by r cube is for the axial line. Okay, those two formulas we should equate and find out. So this is minus q, here it is plus q, here the charges from here, it is at a distance r, this is 2a, and here from the center of the dipole, this distance is r and this distance is r dash. Okay, so O and O dash I am representing. So electric field at O will be equal to electric field at O dash. What is the formula? 1 by 4 pi epsilon 0, axial line it is 2p by r cube, that will be equal to 1 by 4 pi epsilon 0 p by r cube. 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, p and p will get cancelled. So we will get it as r cube divided by r dash cube equals 2. So we can write it as r by r dash equals, it is cube root of 2. So next one is, an electric dipole consists of two charges of plus or minus 0.1 microcoulomb separated by a distance of 2 centimeter. The dipole is placed in an external field of 10 to the power 5 Newton per coulomb. What is the maximum torque does the electric field exert on the dipole? So here the values which is given as plus q minus q. Charges is given 0.1 microcoulomb by a distance 2a equals 2 centimeter. It is given. The dipole is placed in an external field of 10 to the power 5 Newton per coulomb. So E also given as 10 to the power 5 Newton per coulomb. Maximum value of torque. Torque, how we can find out? P cross E. Torque tau equals P cross E. PE sin theta. When torque will be maximum? Sin theta equals maximum. Okay. So here the given values are Q plus or minus Q equals plus or minus 0.1 microcoulomb, that is plus or minus 0.1 into 10 to the power minus 6 coulomb, and then it is separated by a distance of 2 centimeter, that is 2 into 10 to the power minus 2 meter. Okay, then what is the maximum torque? To maximum we should find out. For that, electric field is given as value only, it is 10 to the power 5 Newton per coulomb. So tau will be equal to P cross E, therefore PE sin theta into vector n, but here magnitude alone we should find out. For that, PE sin theta is maximum value of sin theta is 1 when theta equals 90 degree. P into E. P how we can find out? Q into 2A into E. So here Q is 0.1 into 10 to the power minus 6, 2 into what is the value of 2A, 2 into 10 to the power minus 2 into E value is 10 to the power 5. So here you will get it as 0.2 into minus 8, so minus 3 Newton meter. Okay, so torque, unit of torque is Newton meter. Okay, R cross F, that is enough, right? So you will be getting it as Newton meter. Next question. A dipole consisting of an electron and a proton separated by a distance of 4 into 10 to the power minus 10 meter is situated in an electric field of intensity 3 into 10 to the power 5 Newton per coulomb at an angle of 30 degree with the field. Calculate the dipole moment and the torque acting on it. Okay, so the charge of electron and proton means it will be equal and opposite charges, right? So it is given, charge of electron is given, separated by a distance 2a is given, and electric field is given, angle theta also given. So we can find out the dipole moment P equals Q into 2a. Okay, this torque equals P sin theta. P is given, A is given, theta is given as 30 degree. So those questions and all you can do. So I think this is easy, right? So just along with that, please don't forget to read the textbook. Okay, reading the textbook and pointing out all the important this points and formulas, that is very, very important. So please don't forget to do that. Okay, and revision, that also important. Every week you should try to revise everything. Okay, so next class I will be coming with a continuous distribution of charges and Gauss law. Okay, some numericals I am giving it as homework. Please try to do that. I hope it is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.